When SQL has just one record you're looking for on a highly selective field that's covered with an index, it's probably going to do a seek. If there are millions of records in the table, and you only have 5 records that have an invoice ID of 1, that's still pretty highly selective, and if it's covered, that should also do a seek. But in order to know exactly how selective each value of each field is, SQL would have to scan the entire table of millions of records, and that would be slower than just scanning the records when you ask for the information. How does SQL Server know how selective each field is without doing an entire scan when you call upon the query? It's the same way you would know if I were to tell you that there are 7,000 records in this table, and you're only allowed to look at 12 and make some inferred decisions based on that. Well, just looking at these 12 records, I would say the invoice detail ID is unique, which is very highly selective. The invoice ID, that looks pretty selective. Now, the product ID and quantity don't look quite as selective. It's hard to tell. We probably have to sample more data. So statistics are a histogram of values in your table and how selective they are in that table. Sometimes statistics are gathered by scanning the entire table, and sometimes statistics are gathered by scanning a sample of the table. Right now, we're a retail operation with small customers who on the average have invoices with just a few products or just one product. If we later shifted to a wholesale operation where we had invoices with thousands of products on it, invoice ID might slowly become a less and less selective field to query on. So statistics need to constantly stay updated, because a selective field today might not be a selective field tomorrow. Let's choose one of our smaller tables as an example to see what statistics we can see on it, and then see how SQL Server interprets it. Let's go Select All Fields from Human Resources.Room Chart and run it. Okay, we've got 8 records, and we've got an ID that is very selective, and we've got a code, none of those duplicate, and room name, none of those duplicate. A lot of duplicates on notes, and quite a few duplicates on room description, as it has a bunch of nulls in it. Okay, let's get some help on the statistics we have right now. sp_help stats, and then in quotes, we're going to put the name of the table. Now run it. Okay, it shows us that this table has one statistic, called wa_sys, and then a bunch of generated numbers. Let's copy that name, and we'll paste that in a minute, and notice the statistic is on the ID field of this table. The only statistic we're tracking is this field. We're not tracking the other ones. You know why? Doesn't really matter how selective they are. They're not even covered. Let's look at our statistics. Type in dbcc show_statistics, and we'll pass in human resources.room chart, and then a comma, and now let's paste in the name of the statistic that we found on that table. Before you run it, notice we have ID 1 through 8. Now run it. And it says, well, the ID column is 4 bytes because it's an integer. This right here is known as a histogram, and it kind of gives you the spread of values and how many times those values are repeated. For example, ID 3 is listed once, ID 5 listed once, ID 7 listed once, and ID 8 is listed only once. Notice it didn't list every value. This was a sampling. Now in this histogram, you see a lot of records with small numbers of rows. Well, that means that this is selective. But if you see very few values with a lot of rows, that means it has poor selectivity. We have statistics on this ID field, but no statistics were kept on the room name field because there's no index or we haven't ran a query on it. Well, we can force it to keep statistics of selectivity on a field that has no index or we've never predicated on by doing the following. Let's say create statistics. let's call it room chart name on human resources dot room chart, and then in open parentheses, put the name of the field, which is room name. It is considered proper to name a statistic after the table and field name combination that you're looking for. Okay, now run this. A new statistic has been created for this table. Now let's see what SP-help-stats shows us. Look, we got a new name here called room_chart_room name. Let's copy and paste this and show its statistic. Let's see what its histogram looks like. What do these results tell us? It looks like industrial yard is a value that appears once, lumber area appears once, Quinault experience appears once, Renault once, tranquil also just once. Values appearing once means it's highly selective. Here's the good news about statistics. They help tell your query optimizer how selective your queries are so it does the right seek or scan operation. They also automatically update themselves. More good news is, they don't try to burden your system by updating themselves automatically on every insert, update, or delete. They do so periodically, which runs the risk that perhaps your statistics could get a little out of date if a whole bunch of inserts, updates, and deletes took place, and they haven't refreshed in a little while. So you do have the option of updating the statistics yourself. Now we're going to do an example against the customer table. Right now there's not very many statistics on this table, so we're going to create one of our own. Type create statistics, and then we'll name it customer_customer type, because we're going to put it on the customer table on the customer type field. So in this parentheses, we'll specify the field. Okay, let's run this. Commands completed successfully. Now, let's see what statistics are on here by doing SP_help_stats, and in the single quotes, let's put the name of the table, the customer table. All right, let's run this. Okay, we have the auto-generated statistic, and we have this one that we just created. Now, we want to update the statistics, or do we want to update just one of the statistics? Let's take a look at the customer table by expanding Object Explorer, expanding tables, expanding customer, and let's go to indexes. And let's say we're worried that this non-clustered index might not have the right statistics on it. So we're just going to update the statistics for that non-clustered index. Well, let's go back to our query window, and let's type update statistics on the customer table for the non-clustered index called NCI customer type. Let's run this. Commands completed successfully. So it didn't update every statistic, just the one relating to that particular non-clustered index. Okay, what if we wanted to update all of the statistics on that table? Well, it's very similar. You type update statistics and then just the name of the table. Let's run this. Commands completed successfully. Lab 12.1, Skill Check 1. Create a statistic on the DBO Sales Invoice Detail table called Sales Invoice Detail _quantity. When you're done, show this statistic is present by running the SP-help-stats system stored procedure. When you're done, your results should resemble the figure you see here. Skill Check 2. Update the statistic you created in Skill Check 1. Skill Check 3. Show the histogram for the Sales Invoice Detail _quantity statistic.